The next step is probably to understand the storyline of the model, what the code is actually trying to do. So here on the right we have a grid of 100 by 100 little squares. Each one of these little squares we call a cell, and in our model each one of those cells represents a person. So each cell or each person is categorised in one of three ways. They're either susceptible to the disease, or they are infected with the disease, or they are immune. And that immunity can either be something they already have before the disease starts to spread, or they become immune by getting infected but recovering. So we have susceptible, infected, or immune. And these three categories are represented in our 100 by 100 grid in three different colours. So if you're susceptible, you're coloured green. If you're infected, you're coloured red. And if you're immune, you're coloured blue. So we start by setting the board. Each cell is characterised as either susceptible or immune, so green or blue, and we start the outbreak near the centre of the board. Some of the cells are randomly allocated to be infected. From there, if we let it run, the model selects a random infected cell. There is a chance that this cell now recovers and goes from red to blue. If not, it infects one of its neighbouring cells, and the model chooses at random whether this is the cell directly above, directly below, just to the left, or just to the right of that infected cell. And the model then repeats this, randomly selecting an infected cell and seeing whether it recovers or it infects a neighbour. And we get these patterns of green and blue and red cells working their way across the screen. And the simulation will keep doing this until it runs out of infected cells. At this point, the disease has run its course and there can't be any more infections. The model then tells us what proportion of the 100 by 100 cells, that is our population of 10,000 people, got the disease. So that's what the model does.